Okay, so a ball is such that it's dropped from a height of 1 meter. Okay, this is a ball and it's dropped from a height of 1 meter. Okay, bounces vertically from the ground to a height of 0.96. So 0.96 bounces up, continues to bounce on the ground, and each time the height is reduced. Okay, so after this we'll go down again 0.96 and it'll jump back up to a height of, these models will tell us that. Okay, so this is the basic visualization. Yep. Okay, so the part one says that the total distance traveled vertically, so total distance, that just tells us that we have to use the sum formula. Okay, traveled vertically up and down, okay, by the ball from the first time it hits the ground until it hits the ground for the 21st time. Okay, so these are like 21st, so n should be 21. So this n is basically like the number of bounces. Okay, so now that we understand this, let's dive deeper. It says that from the first time it hits the ground. Okay, so after this it hits the ground and it goes back up. So after this we have to calculate the total distance. So what I can do is I can just like cancel or like cut out this 1 meter bounce, because it says from the first time it hits the ground, right? So because I've done that, so now the total number of bounces is like reduced by 1. So now I have n as 20. Okay, so now that we know this, let's first solve part A. Okay, so it says that travel vertically up and down. So what I can do is I can make separate AP progressions, one for up and one for down. Okay, so now we initially had the first time as 1 meter, right? Now that I've cut out this 1 meter, I have the first time as 0.96. Okay, so 0.96. So the model A says that height is reduced by 0.04. Okay, so this should be 0.92 and this should continue. So this should also be 0.96, because you saw here that no, it's going up and then down from the same height, right? So this should be 0.92 as well. Okay, so now we have the first term as 0.96, we have n as 20, and the common difference is negative 0.04 because it's like decreasing, right? Okay, so I will use the sum formula, which is n over 2 plus n minus 1 d. I have n as 20 and 2 is 0.96, 19, 20 minus 1, and then negative 0.04. I'll get 11.6. Okay, so I've found for the upwards. Now for the downwards, I'll do the same. But what you have to notice here is that these terms are the same. Okay, so I've already calculated, for 1, so I can just multiply this by 2, because this will be like the same sum, right? So the final answer will be 23.2. Okay, you can separately solve this as well, but the more convenient way is to like just multiply it by 2. Okay, so let's solve the same thing by model B. Height is reduced by 4%. Okay, so it's reduction. So what you have to do here is 100 minus 0.04. Saying this is from like O levels, so you should know this. So this will be like 0.96. So our R value for this geometric progression is 0.96. And our N is 20, just like I explained here, the same thing. Okay. So the first term will be 0.96. Okay. We'll use the same concept of up first and then down. Okay. So the sum formula is A 1 minus Rm 1 minus R. So for, okay, let's plug in the values. We get 13.39. So I'll multiply this by 2 because you have to calculate the total distance for upwards and downwards both. So this will be 26.8 or 7 meters. Yes. Okay, for part B, for part 2. Show that under model B, even if there's no limit. So the ball is basically bouncing like infinite times, so sum to infinity. Total vertical distance traveled. Yes. Cannot exceed 48 meters. Okay. So what we can do is, let's just, for the upwards, like it goes infinitely up, not infinitely up, but like bounces and then goes up infinitely. Okay, so sum to infinity, 0.96, 1 minus 0.96, you get 48 divided by 2, that's 24. So I'll multiply this by 2 because we've just counted the upwards. I also have to count for the downwards. So we get 48. And that's it. That's the question. It wasn't even that hard. You just need to like visualize. I'll admit that while you're in exam conditions, this might seem very tricky. I'd also mess up because need a lot of understanding and stuff. But yeah, that's it.